All right, so here we are, Module 5, and we're going to be talking a little bit about file sizes and different type of hardware components that go into a computer. So the first part of this PowerPoint talks about binary. I have a separate video talking about binary and hexadecimal, so I'm going to skip this part of the PowerPoint. But I will start talking about the different file sizes. So a bit is the smallest unit a computer understands. It's a 1 or a 0, and that relates to our CPUs. We said CPUs have millions of transistors on them, and each transistor is a switch with no moving parts. So it's a switch. It's either on or off, which represents 1 or zeros. That's why we use binary, and that's why we use transistors. A byte is the smallest unit that a computer understands that creates a character. So 8 bits equals 1 byte, which would represent the letter A or the number 2 or whatever. Now, 1,000 bytes equals 1 kilobyte. 1,000 kilobytes equals 1 megabyte. 1,000 megabytes equal a gigabyte. 1,000 gigabytes is a terabyte. Bigger than that is a petabyte. And if we wanted to keep going, we could talk about exabyte, zettabyte, yottabyte, and brontobyte. Brontobyte is named after the brontosaurus, the largest dinosaur to roam the earth. Right now, most of what we talk about as far as RAM size or hardware, how big is your hard drive? We're talking about gigs and terabytes. But as data centers and AI becomes more popular, we'll need more room and space to store things, and you'll start hearing some of these other names, right? The other file sizes. So it's kind of interesting. I will mention this, a couple things for you to note for the test. Notice on the PowerPoint, so I'm not including the picture here, the largest file size we've listed is a petabyte. Now, don't be confused here, but sometimes when we're talking about file sizes, we're saying it's 1,000 megabytes equals a gigabyte. Other times, we use 1,024. So technically, if we look at base 2, it'll be 1,024. So depending if you're talking about like a hard drive space or the context of what you're referring to, they might say it's 1,000, or it might say it's 1,024 bytes or gigabytes or whatever. So let's talk about throughput. Throughput is how fast data goes through a wire or data goes through your computer. And we measure it in bits per second. So kbps is kilobits per second, megabits, gigabits per second, terabits per second. Now, it's not to be confused with bytes. So if it is a lowercase b, we're talking about megabits per second, right? 1 or a 0. If it's a capital B, we're referring to bytes. So this would be, megabytes per second, which would be 1,000 bytes, not 1,000 bits. So it's a little confusing, but you want to notice a capital or lowercase b because that tells you something. How fast is your computer? Well, if you go to this website here, over here, and hit go, it will test your connection speed to the internet. How fast can you upload documents and how fast can you download? Typically, we need to download more data quicker than we upload. You'll upload a PDF to Canvas, but we're downloading video games and YouTube videos and things along those lines. So you can see here, it's tracked my download speed, and this is a small b, so this is 153 megabits per second. Now it's just finished my upload speed. Again, it's in bits. It's 81 megabits per second. And this is typical, that your download speed is faster than your upload speed. So check that out on your own, see what you have. Um, Now we're just going to talk about processing speed on the processor. How fast does your CPU work? Well, a couple things here. First, it works in cycles. So you can think of somebody clicking their fingers, and every time you click your finger, a cycle or a process gets run, right? And we measure these cycles in hertz. So 1 hertz is 1 cycle per second. It's something like that. That's really, really slow. You can have megahertz and gigahertz per second. So the faster that clock speed, that clock cycle can go on the processor, the faster it can process information and the faster your stuff gets done, right? Things get done. If you go into Task Manager and look at the CPU, you can see how the speed. So this, according to this right here, is 3.99 gigahertz. That's the clock cycle. And you can read some other information about your CPU, how big it is, how strong it is, how fast it's going. If you want to know your current clock speed, though, here is the command that you can follow. So if you go to your command prompt, so you just down here you type in your search bar CMD, and you come up with your command prompt there, and then you type in this code, right? It will give you. So here's my command prompt. I type in that code. Oh, I thought I could. Well, I typed in the code up here, and you can see that my current clock speed is 2900, and my maximum clock speed is also 2900. Here's another example. So here, when I did it in the past, my clock speed was 1910, but I could get up to 2112, right? So this kind of tells you how fast your clock speed is. So go ahead and pause the video, kind of type that into command prompt, check yours out, and it's kind of interesting to see. Now there is something called overclocking, and what overclocking does is each processor is meant to go a certain speed. Sort of like, a moped has a certain top speed, a motorcycle has a higher top speed, a car has a higher top speed, right? A little Fiat, it goes slower than a Formula One car. So you can think of different processors designed to go different speeds. But you can tell your CPU to go faster than it's supposed to. So that hertz per second higher than what it was designed to. And if you do that, be careful, because that ruins your warranty. So if anything happens to your computer, they won't cover it. But over time, that higher speed generates more heat and could damage your computer. Sort of like in your car, if you took your car and you, on a stretch of a highway, got it up to 120 miles per hour, would your engine blow? Well, probably not if you just got up there, stayed there for a few seconds, and then came back down. But if you stayed at 120 for an extended period of time, eventually your engine would have issues, right? It would have mechanical failures because it was not designed to go 120 miles per hour. That's what overclocking is. So let's talk about why my computer runs fast or why my computer runs slow. And we're talking about throughput versus clock speed. So I just explained clock speed to you, right? That's how fast the CPU can cycle through instructions. Throughput describes how much data can get through the wires or processed at the same time. So think of it this way. The clock speed is sort of like the speed limit on a highway. The throughput is how many cars can get through in a particular amount of time. So even though the speed limit is 65 miles per hour, you can't always go that fast, right? There's accidents, there's traffic jams, there's rush hour, right? And so sometimes, even though you might have a higher clock speed, your throughput is very low for various reasons. There is, in every computer, there is some type of bottleneck. And a bottleneck is one component that slows everything down. So you might have a really great processor, but you don't have a lot of RAM. And if you don't have a lot of RAM, the processor can only handle so many instructions. Or maybe your bus speed on your motherboard is slow. So you got a lot of RAM, you got a great CPU, but the bus or the speed limit on the wires to go from RAM to the CPU might be lower, and that slows you down. So there's always one component in your computer that's slowing everything down. That would be the bottleneck. All right, let's move on. So this slide is just telling you the types of data computers can work with. So it can work with numbers, which is an integer. It can work with decimal, which they call a floating point. Characters we're familiar with. So these are like the letters or symbols. Or could use a Boolean logic value, which is either true or false, right? This ASCII and Unicode here we'll talk about next. So in order for a computer to know that this set of ones and zeros, this byte of information represents the letter A, every computer in the world has to agree to that. So every computer in the world uses the same code. And there's two main codes out there these days. One is ASCII, the other one is Unicode. ASCII's older, and the original ASCII only had 7 bits to represent characters, so you can only have 128 possible characters. More popular today is extended ASCII. Extended ASCII uses 8 bits for a character, so it can have up to 256. So let's just say on a test, someone's asking you, how many characters can be represented in ASCII. If they just say ASCII, maybe it's 128. But if they say extended ASCII, make sure you put down 256. Now that's versus Unicode. Unicode is an updated version of ASCII that uses 16 bits or 2 bytes to represent one character. And because it's using 16 bytes or 16 bits or 2 bytes, sorry about that, it could have over 140,000 different characters could be represented using the Unicode. So this way, not only will it include English characters, but also characters from other languages. So let's go to this website here and I'll show you what I mean. So here's some Unicode right here. The first ones are all English, right? And you got some symbols up here that are represented. And if I go down here and say, look at Arabic, right? Here are a bunch of Arabic symbols that are also part of Unicode. You can see the different languages and different symbols that Unicode can represent. You can also see these values over here, the hex values that represent. So this is 60A, right? This is 60B, 60C. So Unicode is written in hex. Okay. There we go. And then again, this is an ASCII. This is an enhanced ASCII chart because you can see it has 8 bits. And I just wanted to point out that a capital A and a lowercase a are different symbols as far as ASCII is concerned. So they have different byte of information, a different number that represents them. All right, I'm going to hold up there. That's kind of the first part of this PowerPoint. And we'll come back and we'll talk about what's inside your computer next.